Hello everyone, welcome to our presentation, Atomic Design, a Recipe for Success. So you're probably thinking, here's another talk about atomic design, so it's true. It's going to be another topic about the atomic design, but today it's going to be a little bit different because we're going to try to actually showcase how to successfully, at best, implement it in order to find the best recipe, the recipe for success. So first, a few words about us. My name is Sandy, I'm a front-end developer and consultant at Publicis Sapient Engineering. And I've been developing for the web and iOS for 6 years now. And on my side, there is Randa. Hello, Randa. She's also a consultant at Publicis Sapient Engineering, and she's an iOS developer. She's been developing for 10 years for iOS product, and she used to be a game developer. That's super cool. So in today's presentation, I want to ask the question, so why we need a design system? But the real question is why we need a system. So I'm going to try to give you a quick definition. A system is useful to bring standards, guidelines, conventions. And the original author of the atomic design, who is Brad Fost, he got the inspiration from other industries like airplanes, ships, and chemistry. So we can imagine that to build a ship or an airplane, you would need a project, a plan, an architecture, instructions, and then engineers to implement the architecture and then the instructions. So this means that, generally speaking, for any project, you need a plan, you need a system. And that's the same, actually, for design and product development as well. You need a plan and a system, hence the design system. And you have different ways of expressing it. You can call it design-driven development, or even atomic design-driven development, but we're going to stick to atomic design for this talk. And this leads us to the following part, which is to look behind the anatomy of the atomic design, the building blocks. So first, a few words about the original author, Brad Fost. He's a web developer. He first came up with the idea of the atomic design 6 years ago, and he came up with the name and the concept thinking about his chemistry class. Remembering that with atoms you can create molecules, and knowing that the whole is made of elements, and elements are comprised of atoms. So this is what I'm showing you next, the building blocks of the atomic design. First, the atoms, which is the smallest part. One example could be a button, a text field. And to create a molecule, we then need two atoms, or atoms, to combine them together to then create a molecule. And one example could be if you combine a button and a text field, you could get a search field. Then after that, you've got the organism, which is a combination of molecules. And a molecule is like a standalone component that you'd see on your app or website. And one good example could be a login form. Again, we see atoms like an email password field and a button. After that, you got the template, which is like the wireframe, with no content, no style, no color. It's just like the skeleton of your screen. The final stage of the atomic design will be then the page, which is what you see on your screen. So this is the final user interface, what you'd see on your website or your application. That's the final stage. So these are the 5 stages of the atomic design, but this is not limited to it. Actually, later on, you're going to see that you can certainly change or extend from it. So I'd like to explain this further. So now we're going to leave the chemistry classroom, and we're going to get into the kitchen. And for this kitchen presentation, I want to prepare a pizza. So I have no idea how to make a pizza, so I'm going to use one recipe. To make my pizza, so I'm going to use ingredients. And there is this dough, which is the starting point of making the pizza, which is my element. And the ingredients we can interpret as the atoms. Again, the analogy with the chemistry. So I'm going to use flour, salt, and water to then make the dough. Next, I want to prepare the sauce. So again, I'm going to use a combination of ingredients like onions, garlic, pepper, and even mustard to make my sauce. After that, I'm going to finish my recipe by adding some toppings on my pizza, like pepperoni, mushroom, pickles, and even cheese. And so I'm done with my recipe. So now we're going to leave again the kitchen. I'd like to get more practical. We're going to get into one web showcase. I'm aware that we are mostly iOS developers in the room, but this is just to illustrate the point. of why we need a system. We just use a recipe to make the pizza, so now we're going to use a style guide. So on this style guide, we have specification about the font size, font families, and also headings that we see on the left. Below, we have components and customization and an example of a use case. This use case was actually created using this specification that we could see actually as ingredients. Below on the same style guide, I have other ingredients like colors, primary, basic, primary, and secondary colors, also ingredients. And this website was done using this exact same specification on the style guide, like a recipe. And this is an actual website. This is actually the FrenchKit conference website that took place 2 years ago in 2018. And on the same website, we have one example, the Contact Us button, that I'd like to take as one example to create the button. So we're going to get into something more like web-oriented. What I'm going to do first to create this button is to create an HTML document. And line 8, you can see that I have a button tag. So I'm going to start with that. After that, I'm going to define the CSS, the styling. And this styling, I have the background red to get this color on the left. And this is what I'm going to add right on my HTML documents within the style tags to add the color, the styling, and get this result. So that's one way to do it, which is perfectly acceptable. And now we have another way to do it, which is also acceptable. Both ways are actually perfectly acceptable. But the only concern is that we now have 2 ways for the exact same result. So that's 2 ways, 2 recipes. So you're going to see in a moment my point, because this was a very basic example, so that's fine. But let's say that you're working on larger projects, on a larger team, so this may start to become problematic. When you know that you have multiple products sharing similar features, or when you have teams changing frequently. And also when you have designers and developers not working closely. And finally, as we have just seen, when you have different implementations for the exact same result. So this may lead to chaos. That's a very strong word. Actually, I'm aware, I own it. But this is what can happen if you're not working with standards. And you may end up writing wet code as opposed to stay dry, which is don't repeat yourself. And the negative effect of not working with standards is to create code legacy when your goal is actually to write code which is maintainable and scalable. And so when you're not working with standards or guidelines or conventions, you end up repeating things over and over, doing lots of repetitions, and so you're not able to optimize your workflow. And so the bottom line, that's what we need to keep in mind, is that if you are able to combine the 4 together, so to work with standards, to stay dry, to write code which is scalable, and then to save time, then you can better guarantee the success of your design and product development. So it's like when you are in the kitchen and that you want to guarantee the success of your cooking, you want to use a recipe with specifications, measures, and the right ingredients. So now that we've seen a practical example, I'd like to show you some steps methodology, so from experience, before we go into one showcase with iOS and full Swift. And what you want to start to do in order to find the right recipe is to start to find any inconsistencies in the UX and UI because of a lack of documentation or no common grounds. Further to that, you want to start doing some research, like UX research, brainstorm ideas, even do some user testing. And also one good thing is to start to make an inventory of useful elements that you want to add in one style guide. After that, you want to start to put things together by defining specifications, standards, guidelines, and even to write one documentation, which will then lead to one style guide, which will be the foundation for a shared library of UI components, including semantic, isolated, and reusable UI elements. And this is not just about creating a system. It needs to be more inclusive, to be seen at a larger scale, by including not only developers and designers, but also UX researchers, as we have just seen, but also PMs, product owners, in order to create a digital ecosystem, which will allow you to then represent your brand and identity of your organization. So this will be the end before I give the floor to Randa, who's going to make a showcase how to go from legacy to atomic design-driven development. Yes.
So now our style guide is defined. Sorry. So now our style guide is defined, and we decide to use it on an existing project. So here the problem begins to appear. We have these 2 pages, sign up and login pages of the same project with completely different styles. That causes a headache for the user and complicated its user experience. So next, I will list you all the steps that we have followed to resolve this problem by converting our project to be atomic. First, we regrouped every small and common items. In this step, we end up with colors and fonts regrouped in their folders. Next, we regroup every primitive items. So in this step, we end up with the bottoms, labels, text files, etc., grouped in their folders. Next, we standardize the style, means we replace atoms or particles that doesn't match the design system. If we took the sign up and login screens from before, in which we apply a style guide, we'll find that in opposite of sign up page that matches the design system, the login page doesn't match it because it uses a different font, a different text file styles, a different colors, and a different bottom style. So to standardize this, we should replace this atom by the right one in green. Next, we create some reusable molecules and organisms from the created atoms. In our example, here is a form organism composed by an input molecule and atoms. Next, we put together all the similarities between pages so that we created our template and our pages. So if you took again the sign up and login pages, we can see that they share the same template, which is a form body between a header and a footer. So by applying this template and the standardized atom, we can resolve our problem, and our login page is restyled by matching the style guide. So now we have seen an example from legacy to atomic. Now let's see an example from scratch to go from abstract to concept by an iOS showcase. So in this iOS showcase, we will back into the kitchen and we will continue with the analogy of the pizza. If we took a tomato in which we apply a style, we get either slices or sauce depending on style. So if we compare this in iOS and we apply a style to a UI component, we will get our atom. I will illustrate all of this with a demo. Here again, I will use the FrenchKit charter. I will try to implement my first contact as bottom atom. So if you apply the previous rule to this bottom, we can see that this bottom is composed of a UI bottom and a bottom style. So this bottom style is composed by a primary color, a title font, and a corner. This is what we call particles. So what is a particle? A particle is an additional layer on top of atomic design. It stores all the properties that can be applied to some or all components to style them. For styling, I will introduce you my pizza library. So this is not my restaurant, to be clear. For pizza library, we defined a protocol that store named asset to a standardized store. We defined a struct style, which is a set of properties. A properties is simply a protocol that can be applied to any object. A property can be a font property or a color property. So now we have defined our pizza library. So let's use it in our UI components, the library of all visual components. So first, we defined our primary color particle and the title font particle. Next, we defined our atom by creating a standard bottom and a standard bottom style. The standard bottom style is a UI bottom with a 30 pixel of height, because all the bottoms of the style guide have a 30 pixel of height. They share the same properties, so I fix it here. For the bottom style, for the standard bottom style, I applied the title font particle to the title label and the primary color particle to the background color. I also let the possibility to choose a specific color for a specific bottom, and also I defined two substyles, active and inactive substyles. So what is a substyle? An atom can have many variations. If we took this example of a bottom, it can be plain, bordered, with icon, without icon. So the substyle is the place where we store all these variation of the atom. So now our atom is defined. Let's use it in our project. First of all, we choose the color set for the primary background color particle, and the used font for the title font particle. For our atom now, I defined the active style with no color, so it took the primary color, and I specified a gray color for the inactive style. Now in our view controller, I just created a vertical stack view with two bottoms. I applied the inactive style for the first one and the active style for the second one. And here is the result. So now we will switch to SwiftUI, and we will try to implement the same bottom in SwiftUI. So we create for the same way the particles, primary color and title font. Now for the styling, we need no more our pizza library, because SwiftUI comes with a new modifier, which is bottom style. And he let us style our bottom exactly the same way, so we can apply the particles to the background and fonts of the bottom. We also created the same way the active and the inactive style, the active style with a primary color and the inactive style with a gray color. Now in our view, we create a Vase Stack, exactly the same, composed of two bottoms. We applied the active style for the first one and the inactive style for the second one, and here is the same result. So we have seen how to create a bottom atom. So for the rest atoms like labels, text file, we will follow the same recipe. Now for the other blocks of atomic design, there is a main rule, which is the code reusability. There are two sides of code reusability: the Y component reusability. Here an example of a molecule composed by a label atom in which we apply a label style, and a text field atom in which we apply a text field style. If I create this molecule, because it will be reused in an organism with another bottom atom, and in a template with another label atom in which we apply a new style, which is the error label style. So the other side of atomic design is to isolate the business part and make it reusable. For example, we can reuse the workflow of the form validation, or the implementation of validation bottom, or even the entire feature sign-up. Now we will see the reusability in SwiftUI. So as we know, SwiftUI is designed to make its view easy to reuse, and even the last update of Xcode 12 make it more accessible. So you can take any of your custom views and add it to the view library. This is by creating a struct that implements the library content provider and overriding library item to return your custom view. So if we took our previous bottom stack view that we have created, in which we add the code above, so our bottom stack view will appear in our view library. To use it, just drop it in a new content view, and here is the same result. So, to conclude with some food for thoughts, atomic design is a powerful concept to create companies' ecosystem, but be sure not to be overkill. So, actually, here are the steps to help you find the perfect recipe to create a design system, the recipe for success. Thank you.
So we won't have questions with the microphone because yeah, we just have 2 microphones today. First question is when your app as an app or website has a lot of atoms, of molecules, how can you help your team find them? One of the sub-questions is should be like the designer team that should give it to the developers the name of the atom of the molecule to use. So let's use the atom, the molecule foo, and you will find it somewhere. Or left to the team to find the right molecule for a given screen.
Do you want to answer?
So, as we have seen, this is work for both of them. The designer team and the developer teams should work closely, so it can have the same naming and share the same documentation, so that if, for example, a designer called this contact as bottom, so in my code also I will have this atom called as the same as the designer called it.
Do we have a question on the audience? Okay, so
how do you adapt the design system to each platform and take care of being compliant with guidelines and stuff like that?
Very good question.
Each platform means, for example, if we have many platforms working at the same.
For example, those navigation patterns are navigation patterns part of the design system, or it's just about the UI of the component? For example, tab bars, or do you use a native tab bars look and feel on each platform, Android and iOS, or do you have a shared?
Oh, okay. It depends on style guide. So sometimes the designer decide to keep the identity of the platform. For example, we keep the navigation of iOS, and we keep the navigation for Android to keep their identity. Sometimes they decide to make something uniform for both of us, so both of us have the same components, visual components.
And when they are different, do they have different names in the design system, or it's just, for example, the tab bar, and each platform knows what's a tab bar in its platform?
That's a good question. Generally, we try to keep the same naming, so that both of us keep the same naming, and if for example a designer updated this component, all the technology will be updated the same way. So I don't know if I answered.
Yeah, totally.
Okay.
Okay, thank you very much.
Thank you.